So I'm Bob Allkin, as Elke said, and Christina Fatmore is my colleague here at the back. She's also works for Kew Gardens, but lives locally here in Uppsala. So I'm hoping that Christina will be around in more sessions that are to do with herbal medicines during this course, and other opportunities for you to exchange. And our task today is to convince you that plant names are important. So I'm not going to be talking about plants, but just their names. So I'm sure that sounds very boring to you, but I'm going to convince you otherwise. This is Kew Gardens there behind, and this plant in the front is Meadowsweet. It's a plant I really rather like. It's a native plant in England and is used for various purposes. It doesn't grow in meadows, and it's so strange that it should be called Meadowsweet. And the only explanation that I've ever heard is that it is actually used to make mead, which is a sort of honey-based alcoholic drink that was made in times past. And though this is not the Meadowsweet, but the mead sweet, actually is the name of this. And so this just illustrates how common names can actually evolve. So here I am, an Englishman in Uppsala, and so I cannot possibly not mention Carl Linnaeus. We are in the Linnaeus Hotel. This great man's house is just across the road, and I do hope that while you're here in Uppsala, you have an opportunity to visit his house and the museum and learn a little bit more about his work. The Swedes have not forgotten him, so however long ago he was here. So as I was saying, common names can be problematic when we're thinking about communicating effectively. I should just say that every time I work with people or talk with people that are working in pharmacovigilance, I'm impressed at the breadth of knowledge that you must have. And I'm going to talk just about one very small little component. So as I suggested earlier, common names are problematic, or can be. One plant will be known by different people in all sorts of different ways. And that's, yes, because of language and place, but also within a different country. So one plant can have many names. This is a plant I know as bluebell. If you walk in any woodland in southern England at this time of year, it will be blue, a carpet of blue and lovely. But my best friend is a Scotsman, and this is what he calls a bluebell. And if you go on to Google, you find that Australians and Americans and goodness knows call all sorts of different plants bluebell. So not only does one plant have many names, but one name can refer to many plants. And so if you come to find out, so what can I use ginseng for? Then the question I ask you is, but what is ginseng? And ginseng has been used in various medicinal products derived from many different plants. In fact, we are aware of 12 different species of plant which have different chemistries and different uses, but they are all, in some shape, form or other, labeled ginseng. And this, of course, has serious consequences, this confusion. So Fangji is a Chinese traditional medicine product. It's in the Chinese pharmacopoeia. Stephandia tetandra is the one plant from which it is derived, has particular chemistry in use. And then Fangji is also used in the Chinese pharmacopoeia to refer to another completely different product derived from a different plant with a different chemistry and a different use. And that's fine if you know what you're doing and you're aware of that dichotomy. But tragically, in Belgium, in 2008, one of these products was substituted for the other, and some people died, and many people ended up on dialysis for the remainder of their lives. So this happens in Western Europe, but it is equally important in countries like I worked in northeastern Brazil, where 70% of the population were depending on the use of herbal medicines. They don't have the luxury of going to the pharmacy. And in those instances, it is equally the case. So we were aware of nuns that were trying to help poor communities, giving them medicinal plants. And some of the plants that they were giving to those poor people were poisonous, simply because they were confused by the common name. And then there's all sorts of different classes of name that these pharmacopoeias and pharmacologists start building. So if we look just at this one product, Fangji, it's referred in the British pharmacopoeia as Stephania tetandra root, whilst the European pharmacopoeia calls that Stephania tetandri radix, a little bit posher. And then the US Herbs of Commerce, which is intent on keeping the common names all in one place, said it's two different versions of the thing. So which of these names here are scientific plant names? Any votes? Anyone like this as a scientific name? No, no. This one then. Yes? No. None of these are scientific plant names. None of them. They're written in Latin, but that doesn't make them a scientific plant name. So what is a scientific plant name? Well, yes, it's written in Latin, although that's accidental. It's almost not important. And then you would expect the genus and the species, and you would expect the name of the person that published that name to appear. Fine. So Hocus Pocus Bob is a scientific plant name, right? Well, it is a wee bit more complicated. So there's the International Code of Nomenclature, which establishes what botanists need to do to publish a scientific plant name and register it. That's what makes it scientific. And there are the procedures to be followed. The author must say why this plant is different from anything else that science and humanity knows about, and they have to say which specimens they are looking at. And those specimens are stored in herbaria around the world. Often they will be duplicated, and those become called type specimens. And the type specimen, this physical representation of what that Latin name means, is why these are scientific. There is a reference point to which you can go. Okay, so my Scots friend and I will never agree about what is a bluebell. But in this case, there is a physical specimen that says this is this plant, and we can go back at it, and we can extract its chemistry, we can extract its molecular, its DNA, and we can say this is what this Latin name means. So Hocus Pocus Bob is not a scientific name. So this is a specimen from Kew. It was collected way back in 1962 by a botanist working there with his collaborator, so Roger Polhill and Paolo, and they collected this plant in a place that was then called Tanganyika. Okay? So some of these collections go way back. And they collected a little bit, what was it like and where did they find it and so on and so forth, and they give it a unique number, 2139. So that specimen will be found in the host nation. It will be found in South Africa. It will be found in Nairobi, in those herbaria, as duplicates of this collection will be there. Polhill and Powell-Hill, 2139. You can go and look at it. Then, subsequently, the man that was the expert on this group of plants came and visited this herbarium, and he saw that this was something new, this was different. And he gave it a new name, Indigofera tinctoria va arcuata, and his name was Gillet. So he created this new name for the very first time, and he published it, citing Polhill and Powell-Hill 2139 as the type specimen. Okay, so you can never, ever, in the future, talk about Indigofera tinctoria va arcuata without knowing what it means. It means whatever is on this sheet. So we use them because they're unique, because they are fixed in the terms that they have a point of reference, and they're global. And for those reasons, they are also used in legislation, including CITES and Medicinal and so forth. So we must use scientific names, but botanists have not made it easy to use them. There are some real challenges to do it properly. The first of those is that there are synonyms. So we know of 390,000 species of flowering plant, more or less, but we know for certain that there are 1.6 million scientific names being published. So there's many, many more names than there are plants. On average, 10 names for every medicinal plant, because medicinal plants are more useful, they've been written about more, people disagree about whether it's 2 species or 3 species or which genus it should be in, and so you end up with more synonyms for useful plants than a plant that's only ever been found once in some remote forest. And one plant that we know of in the British Pharmacopoeia has 500 scientific synonyms. And one of the consequences of that is, of course, that you find it difficult to find everything that has been published about that plant. You need to know that there are 500 synonyms and then go and search Google using 500 names. You won't find all of the adverse reactions to that plant if some people have used one name and other people have used another name. So that's a challenge. The other is that names keep changing. And there is a common view, certainly amongst gardeners in England, that taxonomists just change names for the sake of it, and they want to make their life difficult for the gardeners. But there are 10,000 changes, plant names, published every year. 2 of those are new species of plant, and then because new research happens, and particularly more recently the DNA research has enabled us to understand better the relationships between plants, then plants will move from one genus to another so that they are together with more closely related plants, or this machine is operating on its own here, or a species that previously was recognized, we decide the evidence will show us that there should be 2 species or 3 species, it should be split up. Or the alternative happens, a species found in Bolivia and described with one name, and a species found in Peru and given another name are actually found to be the same thing. And so they come together, and those 2 names become synonyms of one plant. So that's the one plant has many names problem, and scientific names have just the same problem as the common names, in that you can have one name might refer to many plants. And so this example here is of an EU Commission decision. They were worried about a Japanese poisonous plant, and they wanted to stop the import of that plant. And so they said, Illicium anisatum is highly poisonous and you can't import it. But in doing so, what they actually did was to ban the import of star anise that most of us, will use in our kitchen. So this is Japanese star anise, Illicium anisatum, a picture. This is that's the poisonous one. This is star anise, Illicium verum, the one that I use in the kitchen. And you can see some synonyms there that I've listed. And Illicium anisatum occurs as a name for both of them. It is not the preferred name of the both of them, but it is a synonym of Illicium verum. And the Commission did not say in their diktat which of these names they were referring to. So it was ambiguous. And we know of 2 further homonyms, as we call them, of Illicium anisatum, which could actually refer to a 3rd and 4th different species. So the challenges are there are too many names, those names change. We've got this problem of homonyms. 5% of scientific names basically are ambiguous in that way. And then the other real challenge for you is that botanists keep publishing these lists and they disagree with one another. And if you look at the flora of Bolivia, it will give you a different answer to the flora of Peru. And if you look at the world, etc. There's all these different places. Which one do you trust? How do you go about deciding? And this is particularly true as some of these big databases go copying data at a particular point in time, and then they don't maintain it. And so as names change, those quickly get out of date. At Kew, there is a tradition of curating plant name databases and plant taxonomy databases. And I'm just going to say a few words about some of those. So IPNI is an international collaborative effort which catalogues all scientific plant names. Every scientific plant name ever published is in there. And it will tell you if this name exists, where it was published, who published it, and And it is being curated, so there are 300,000 edits to this database every year. It's the de facto standard for scientific names. It's great for taxonomists, but not much use for mortal people, because it doesn't tell you anything about synonymy. It doesn't tell you anything about plants. It is simply a list of scientific names, so of less use to you. But the World Checklist is built on top of that. And what this does is a list of plants, and it will tell you all of the synonyms of that plant and where that plant is found and whether it is a tree or a herb or a shrub, and give some evidence for that. And this is a peer-reviewed effort with taxonomists around the world helping Kew to build this. So what's the right name to use for this plant today? What are the synonyms? Is this plant in Kenya or Peru? And it lists, currently published on the Kew website and visible for your search, are about half of all plants. So, and it'll be done for half of the plant families, actually, so that all the species, all the genera in those families are available. And we consider this to be gold standard. This is the place to go if you really want high quality, reliable information. And like the previous database, this is being actively curated. The problem for you guys is there's another 50% of the plants that's not visible there. So where might you go? So this is very good quality, but incomplete. So the plant list is a project which Kew was involved in together with the Missouri Botanical Garden and a bunch of other collaborative institutions. And this is similar to the World Checklist, but is more restrictive. It doesn't tell you where the plant is found, it doesn't tell you what habit it has, but it attempts to list all the plants in the world. And this was produced first in 2010, but crunching all these different databases together was a significant intellectual and technological challenge. And the result was a very nice list, which was produced in 2010, and is as good as there is for the other half of the time, but it's not being curated, and so therefore is less reliable. But one thing this website does do is to tell you how reliable some of those taxonomies are. So it's 100% complete, which is great, but dodgy in places. So the botanical resources that are out there for all plants conflict. There's a variable reliability. Botanists like to use them, but honestly, they were written thinking of botanists primarily, and they're not necessarily easy. And they don't have common names. They don't have trade names or pharmacopoeia names. So this project, Medicinal Plant Name Services, which is the one that I lead and Christina is working on, attempts to solve this for those working in public health for medicinal plants. What we wanted to do was to take the best of IPNI, the World Checklist, and the plant list, and make that available through a simpler interface to our users over here, people that work with medicinal plants. And we've added to all those scientific names the common names and the pharmacopoeia names. We've included those misspelt scientific names that are used in medical legislation, because those are important. The botanists don't want to know about them, because they're wrong, but of course you use them and you will find them in important books. And so we've captured those together with the correct scientific nomenclature. And so we've built this resource, which currently covers, it's more now than 14,000 species of plant. These are those plants which are commercially used internationally, globally. So we've used the pharmacopoeias and so on and so forth as our source of which plants to include. And we have, for those 14,000 species of plant, we have 90,000 names which are used somewhere within the medicinal pharmacovigilance community. So that includes the pinyin names and the Japanese script names. It includes the scientific names as they actually appear in the pharmacopoeia and the pharmaceutical names themselves. And to that, we have been able to add a further 200,000 names, which are the scientific synonyms in all their glory from Kew's resources. And we've added to that the plant part that is used, the trade form, and then links to other resources. And one of the questions I'd like to ask you guys at the end is what other sources we might link out to that make it more useful to you. So one of the things that bringing this information together illustrates is just how poorly and inconsistently names are used within your domain. So Sisimifuga rhizoma may look posh because it sounds sort of Latin, but it is used to refer to one plant in the European Pharmacopoeia, 3 species in the Chinese Pharmacopoeia, 4 in the Japanese Pharmacopoeia, in total 5 different species and 9 different scientific names. So there is great, this makes me anxious for people that are trying to regulate, and even more patients that are using these sorts of products. And so these 5 different plants look very different. They have different uses assigned to them according to those pharmacopoeias. And again, caution. So having built that resource, we try and make it available. The first thing we have is a portal, a website which is free for you to use and go and ask questions, and Christine is going to be leading an exercise with you about how to use that. But we've also developed a set of what we call professional services. So for the US FDA, for example, we've been able to take all their plant names in their database and correct them. We can detect which names are misspelt. We can propose what they probably meant. If they've got old synonyms, that we can tell them what is the modern name, and we can give them all the synonyms for the plants that they hold. And I was telling one of you over lunch that we were able, in this exercise, to point out that the US FDA had the same plant listed 4 times under 4 different scientific synonyms. They thought it was 4 different plants, and therefore it was regulated in an inconsistent way. So this is the sort of thing that having a terminological control enables you to do. Vocabulary is a control and means us giving people a list of terms for their use locally. In the EU, particularly, the Italians and the Germans and the English and the Belgians, they don't want to talk with one another, and they all have these different names. So what we're able to do, without saying what is the right name, what we are able to do is to map the list of plants controlled by the Germans to that controlled by the Italians, to that controlled by the British. We help people design their workflows and how they collate data. We're providing web services so that the controlled vocabularies that we distribute are kept up to date as names keep changing, and we're offering some training and best practice guides. And one thing I thought just mentioned, I just put this slide in at the last minute, but someone mentioned the ICH and this need for global standards. There is a new medicinal product standard called IDMP, which was developed initially through ICH and then moved on and became an ISO, published standard, and US FDA, EMA, the Dutch regulators and the Canadian regulators and the Japanese regulators are involved in this. It has been adopted by all of those regulators. It has been published as an ISO guide, and we at Q have been involved in helping them define the herbal components. A colleague of mine authored the implementation guide for herbal substances, and we provide a controlled vocabulary for the names of plants covered in these medicinal products, but also the plant parts. And we're offering an API which will keep that controlled vocabulary up to date, and that will be available free of charge to regulators through the world. So the portal, this is the thing that you will get a chance for hands-on experimenting with in a minute, but let me just illustrate how we might use it. So we know that muxiang is a herb in the Chinese Pharmacopoeia. What would be the right name for it? What would be the scientific name? Well, if you go to the floor of China, it's called Aucklandia costus. The Chinese and Korean Pharmacopoeia call it Aucklandia lapa. US Herbs of Commerce call it Susuria costus, and the Japanese and Ayurvedic call it Susuria lapa. And there are a bunch more synonyms. So which of these is right? Does it matter? So if you search our portal using muxiang, you will actually find that there are 7 different plants which have been associated with medicinal products using that name. So this is similar to the ginseng example with slightly fewer species involved. So there is ambiguity. Muxiang might mean a medicinal product from any one of those 7 plants. Okay, now you're able, through the portal, to go and explore any one of those plants. And I'm just going to go down and look at one of them, Aucklandia costus. And this is the sort of information that you get. You're told you can find all the different non-scientific names that are used. You can find out what part of the plant is used and the form of the plant that is being recognised. And possibly more significant for you, I don't know, but I would be interested to hear your views. These are the sort of references that are citing these names on this one. So this one plant is cited in a significant number of pharmacopoeia and other references. If we go over to the fourth tab there, the further information tab, then we are able to go out and search beyond Q's resources and start looking at other people's data. And one of those is to go look for PubMed or to GenBank. And if you search PubMed using this tab here, you will search using just the name Aucklandia costus, and you will retrieve 53 medicinal publications about this plant. However, if you use this tab, which searches PubMed using all of the synonyms that we know about, you will retrieve almost 1,500 medicinal publications about that plant. So PubMed do not know all the information they hold about one plant because they're storing it using different names. So that illustrates why having all these names in one place is useful. And it would be true equally for Google or whatever. And if you have additional resources, be they chemical or adverse reactions resources, which are online digitally, we could be pointing to them and making our website more useful. That's the team that do all of this work. 13 of you responded to the questionnaire we sent out. So I thank you, those that did. There was a slight hiccup around the mechanisms of some of you will have noticed what my intention was that you could, in some cases, you could have answered more than one question. But so I'm not going to correct you. But in fact, the 13 people that answered clearly know a thing or two about plants. The answers were good, much better than when I've had done this exercise with other groups. So congratulations. So there were. They are scientific because they're written in Latin. They refer to type specimens. They never change or they sound posh. 11 people got that one dead right. It's because they refer to type specimens. And, of course, names do change. The names of a plant do change, although they always refer to that specimen. What is a scientific name? Well, it's got a number of different components, as I suggested earlier on. It has a genus, it has a species name, and it has an author name. It wouldn't include the family name because it might yet move to another family, nor date, nor language, or any of that. So again, most of you were spot on there. How many names? Well, I've given you the answer to that question already. It's 1.6 million. But this is sort of right because if you look just about the binomials, the species names involved, then it's just under 1 million at the moment. But it's 1.6 million of names in total when you start including the infraspecies, the subspecies and the variety names and so forth that might be synonyms. And finally, why do they change? So you were very kind. You didn't suggest it was just taxonomists wanted to keep work. Again, every answer I think from you group was correct. And any one of those with a tick against it would have been incorrect. So there's a number of different reasons why names change, and for justified reasons. And a story I like to tell is of a chemist that worked at Kew many years ago, and they extracted a molecule from an Australian tree. And this chemical was extremely valuable in understanding how the AIDS virus replicated. They were able to use it in experiments to understand a little bit more about the biology of the AIDS virus. So they published a very nice paper in Nature, and they got lots of brownie points, and they were very pleased with themselves. The next question was, to understand this more, we want a molecule which is very similar to that one that we have just found. Where would you look for a molecule that was very close to that molecule? Any suggestions? How would you go about finding a chemical that was very similar to the one they had found in that Australian tree? Yep. You look like you have an answer. Well, my answer is that you would look in a species in the same genus, because species in the same genus are closely related evolutionary, and they share chemical pathways. And so you're much, much, much more likely to find a chemical that is similar in a plant which is closely related. Now, the chemists at Kew know that. So they said, right, now we're going to look in other species in that genus of Australian tree. Sadly, there were no other species in that genus. So now they were stuck. So what would they do now? And their answer was to walk across Kew Green and go and talk to this botanist who had long retired but knew that group of plants well. And they said, look, we've got this Australian tree and we're looking for something that's closely related to it. And he said, well, there's a South American genus of tree that actually should be the same genus. We've known that for a long time. We just haven't had the time to publish it. Okay? So they then went off. There were 3 species in the South American genus, and those 3 species of tree had very similar chemicals in them to the one that they were looking for. So they solved their immediate problem. But this is a reason why names should change, because it will help you find and understand the chemistry. So what do you not do? Well, Google, no, sorry. People will call plants differently, and different scientific names can be ambiguous. Okay? I assume this slide pack will become available to the folks here. Okay. You should use scientific names, but nevertheless beware of ambiguity. And you need to be citing some global scientific resource. And I say global because although there are very, very good, valuable lists in Brazil and in Kenya and many other countries, by taking a narrow national view of this nomenclature, you will risk having the same plant in there named differently from those in your in a neighbouring country. So you need to cite which source you're using and the date that you took that information. So where to look? Well, obviously, I would say this, wouldn't I? But if you're looking at medicinal plants, please go to MPNS, because that will pull the best of the taxonomic knowledge that is currently available and make it available to you, and it is being updated. If there is a plant that is relevant to your work and it is not in MPNS, then please let us know, because our intention is to be all-encompassing for this audience. If it's not in MPNS, use the World Checklist, and if it's not in the World Checklist, then you use the plant list. That's the sequence that I would recommend. So thank you very much for your attention. These, I hope, will be distributed to everybody. And we're now going to go on and do some exercises with you, and I'm hoping that each table has got a laptop for searching the web. Okay? Thanks.